Hey everybody, this is Gigi from Kauai Community College. In this video, we are looking at building a truth table in order to show whether an argument is valid. Okay, so by definition, an argument is valid when the conclusion must necessarily follows the premises. So we need to build a truth table for the statement that said premises lead to the conclusion. So premise one, if P, then Q and R. And I would go ahead and put that in a grouping symbol right here. That's to denote that that is premise one. Okay. And premise two, which is not P. And then we want to know premises lead to the conclusion of not Q and R. Okay, so that is what we need to build a truth table for. And we want to know if that is going to be a tautology, right? Build a truth table for this statement right here. Okay, so here we go. In order to build a truth table, we think about our simple statements. We have three of them: P, Q, and then we have R. So we have 8 possibilities of truth combinations. And then to go ahead and list out the order, I would go inside first, parentheses first, right? So Q and R would be my next column. And then I would say P implies Q and R would be my fourth column. And then I would say not P, because negation will come before N. And so in here we have the whole bracket there. Okay, I'm gonna short cut that. And the thing is and, right? And then and we are looking at column 1, 2, 3, 4, 5, column 5, and column 6. That's what I'm looking at. And then I would say not Q and R. We already have Q and R right here. So now we just need the negation of Q and R. And then we would say the entire statement right here. And the entire statement would be column number 7 to column number 8. Okay. All right, here we go. How do we list them? We would say true, 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 and then 4 falses. Okay, so if there were 8 choices, then 4 true, 4 false, and then we would list our normal true, 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 false, false, true, false, false, and then repeat true, 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 false, false, true, false, false. And that's how I systematically list all 8 of them out that way. All right, so here we would say Q and R. Q and R. So and means you have to have both for it to be true. So true and true is true. This is false. This is false. This is false. True and true is true. This is false. This is false. And then this is false. Okay. And then we would say if P, then Q and R. So we are going from here to here. Okay. And the arrow goes that way. So if true, then your statement is true. If true, then false, your statement is false. True, then false, your statement is false. True, then false, your statement is false. And then if false, it doesn't matter what, your conditional statements stay true. So this would be true, 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 and true. All right, now not P. Not P is the opposite truth value of whatever P is. So we would say false, 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 true, 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 right? The negation of P. And now we are looking at column number 5 and column number 6. And we are combining that with the and. Okay, so and means both have to be true in order for it to be true. So we have false, 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 false. And then these are all true, 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 true. And then here we would say we have the negation of Q and R. So that would be the opposite truth value of the green column. So opposite of that would be false, true, 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 and then false, true, true, true. For the last entire statement, we are going from premises lead to the conclusion. True implies, false imply anything is true. False imply anything is true. False imply anything is true. So this one is also true. However, if you see true implies false, then this is false. And we can just stop right there and say it's invalid, because valid means it has to be a tautology, always true, so that the premises will always lead to the conclusion. But, if we really did fill in the whole entire truth table, we would see these are true right here. But this is the problem, and that is why it is invalid. And invalid in form, right? The structure of this argument is invalid. And if you really recognize this right here, this right here really is fallacy of the inverse. Fallacy of the inverse. So that is why it is invalid. The inverse is when we say not P, then not Q, right? So if you recognize it in the first place, you didn't have to build a truth table. And then otherwise, you just build a truth table, just to be sure, right?